Swinburne University of Technology.
Hi everyone, welcome back for week 11. This is the last week of new content, so this will be our final topic that we're looking at this week. From next week we'll just be looking at revision and exam preparation. So this week we're going to be looking at another new test, which is called the chi-squared test. So where we see the CHI, it's pronounced chi, it's a Greek letter. And a chi-squared test that we're going to be doing is for looking at the relationship between two categorical variables. Okay, before we get into that though, let's warm up our brains with a brain teaser. So multi-choice one this week. We've got 4 statements there, and I would like to know which of those statements is true. I want to pause the video if you like to just have a quick think about it. So, if one of these statements is true, then that means that 3 of them must be false. So our answer is C. We have 1 true statement, which is C, and therefore we have 3 false statements. Okay, so this week we are looking at the relationship between 2 categorical variables. So, for example, here we have a table and it's got some counts. So frequencies for males and females and whether they are satisfied with their car or not. So when we see a table like this, it's got a few different names. Sometimes it's called a frequency table, but it might also be called a 2x2 table or a two-way table or a cross-tabulation. This particular table we're looking at, one of the problems with taking a lot of meaning out of it is the fact that we have a different number of males from females. So we can't just look and go, well, there was 30 satisfied males and 20 satisfied females, because there was a different number of males from females. So really what we need to be focusing on instead of the counts is the percentages. So here is a cross-tabulation out of SPSS for car by gender. But what you'll notice is that we have row percentages. So we have the percentage of males and the percentage of females for satisfied and then for dissatisfied. So of the people who were satisfied, 60% were male, 40% were female. But that doesn't make any sense for us to try and interpret. If we're trying to look at differences between males and females, this is not the percentages that we want to be looking at. This is quite an important thing when we're looking at these two-way tables, is making sure that we have the correct percentages, so either the row percentages or the column percentages, depending on what we're wanting to interpret. It's also one of the more challenging parts of dealing with these kind of tables, is being able to correctly interpret the percentages. So let's have a look at column percentages instead, because this is going to be much more sensible. So now we're saying for the males, 30% were satisfied, 70% were dissatisfied. For the females, 40% were satisfied, 60% were dissatisfied. So this is much more sensible than looking at the percentage of men and women within the satisfied group and the percentage of men and women within the dissatisfied group. So really important we've got our correct percentages, and so now we do. And so our whole idea with the chi-squared test is to be able to determine whether there is a significant difference between whatever particular percentages we're interested in. So if we wanted to know whether there was a relationship between satisfaction and gender, so did your satisfaction vary depending on what gender you were, then we're going to use a chi-squared to determine whether there's a statistically significant difference between these figures. Because it's all very well to say this is 30% and this is 40%, but just like with all our other tests, we need to be able to test whether what we're seeing in the sample is actually going to translate into a difference in the population, or an expected difference in the population. So we use the chi-squared test. So the Greek letter chi is this guy here, looks a bit like an X with a little flick at the top and a flick at the bottom, and so chi-squared. If you read other stats textbooks, you might see a picture of the chi-squared. It's got a bit of a funny kind of right skew shape distribution to it. So we're going to be looking at whether or not there's a significant relationship between two categorical variables. And just like all our other tests, the key thing we're looking for is our p-value, and whether our p-value is less than 0.05 or not. So is my p-value less than 0.05? If it is, it's telling me there is a significant relationship there. So we're going to look at two examples today. So for each example, we're going to work through, we're going to look at the chi-squared output, and then we are going to look at the report. So here's our first example. Might want to pause, have a read through the scenario, and then we will start looking at the output for it. Okay, so with this question, we've got education level, and it's 3 different categories, so it's categorical, and whether or not a person is in a managerial role, which again is categorical. So we've got 2 categorical variables, which means we should be using our chi-squared. The groups that we're comparing, we are interested in those with tertiary education versus those with lower education, and whether the tertiary ones are more likely to be in managerial positions. So we're saying that being in a managerial position is going to depend on whether or not you have a tertiary education. So tertiary education or education level is our independent, and managerial position is our dependent. So here is our chi-squared output, and so make sure you look on Blackboard at the SPSS videos for how to generate this. And the first thing that we look at, that we get generated, is our table. So we've got our percentages on here, and so we can see that in fact 26% of the tertiary educated were in managerial positions, compared to 47% of secondary educated, 46% of incomplete. And then we have our chi-squared test table. The bit that is important for us is this top row. So the one that says Pearson chi-squared. So good old Pearson again, seems to be into everything. We don't really need to worry about the Pearson name, but our chi-squared, here's our chi-squared test value, here's our degrees of freedom, and here is our p-value. And we can see that our p-value is less than 0.05. When we're quoting it in our report, we have our chi-squared symbol, so a bit like we had the t, instead we've got the chi-squared, brackets, we've got our degrees of freedom, we've got our equals, and then we've got our chi-squared value, so that came from there, and then our p-value. I'm going to stop scribbling on this page now. Okay, so let's have a look at what our report looks like. So here is our report, just like all the others, same kind of idea. We start off with our hypothesis. First few words, doesn't matter if we're saying it was hypothesized, or researchers hypothesized, or it was just any of those kind of phrases, all fine. Key bit, talking about the groups we're interested in, so tertiary education, more likely to be in managerial positions than those with lower education. So when we're writing a chi-squared report, like the others, we start off mentioning sample, how many in our sample, who they were. The next step is to make a statement about whether the group we're interested in is less likely or more likely. So you can see with this the rest of the sentence, there's no mention of percentages. It's just saying, well, actually, when we look at this table, we see that those with tertiary education were in fact less likely to hold the managerial positions. So we're starting off by describing what we see without using the percentages. Then we back this up with the percentages. When we quote our percentages, we don't quote every single percentage off the table, but we do make sure we quote all of the ones of relevance. So we're interested in percentage of managerial positions for each of these groups. So we need to make sure, if we've got a 2x3 table, that we quote all three. When we're quoting the percentages, it's also important that we compare them. We don't just say there was a percentage of this, there was a percentage of this, there was a percentage of this. We actually say this is less than, this is more than. So we're actually doing a comparison, we're not just stating them. Next step, name of our test. For consistency, just like the others, we should be saying the name of our test. Depending on your version of the textbook, you may find some examples in the textbook that don't do this. I would encourage you, please do state the name of the test for every kind of report. So when we're doing our chi-squared, we're saying that the chi-squared test shows me about the relationship between, and so making sure that I say what the relationship is that I'm actually examining, which in this case is education level and work role. Our p-value is less than 0.05, so it was significant. Quoting our chi-squared figure, our degrees of freedom is the chi-squared stat, is my p-value. And then finishing with our conclusion. So we were hypothesizing that people with tertiary education were more likely to be in managerial positions. As it turned out, they were actually less likely. So we start our conclusion with contrary to expectations, because it was actually the reverse. There was a significant relationship, but it was actually the reverse of what we thought it would be. So contrary to expectations, those with incomplete secondary or secondary are much more likely to hold managerial positions than those with tertiary education. Other key word in here, likely. So when we're talking about our percentages, higher percentage means you are more likely, lower percentage means you are less likely. Okay, so let's have a look at another example. So this example, we are looking at whether someone is in a managerial role or not, again. So maybe this was the same set of business data. And so work role, managerial or not, which is categorical, and work-related stress, low, moderate, or high. So again, categorical, we've got two variables, they're both categorical. Remember, we've got categorical variables. This is the variable name. These are the categories or the groups within it. This is the variable name. These are the categories or groups within it. Really important when you're identifying independent and dependent variables. Okay, so we've got our two variables, the categorical, which one is the independent variable. So we're saying that your work stress is going to depend on your work role. So we're saying that the work role is the one that affects the work stress. So therefore, if the work role, if the stress depends on the work role is the independent, and the stress is the dependent. So let's have a look at our output. So similar kind of thing to before, although this time you'll notice that we've got the three categories going down this way, two categories going here. Reason for that is because of what we're comparing. So depending on which one is the independent variable, which one's the dependent variable, depends on which way around these guys go. This is not an absolute, and in fact some textbooks you'll find that they don't really worry about which way around the columns and the rows go. Others you'll find will try and put the independent variable up the top here and the dependent down the side. So again, I only need to worry about this top one. So there's our chi-squared, big chi-squared statistic. One thing that I hadn't mentioned before, anytime we look at our test statistic, the bigger this number gets, the smaller the p-value gets. So big test statistics always associate with smaller p-values, and we can see 0.00, so very, very small, so definitely a significant relationship here between work role and stress. So let's look at the report. Again, starting out by describing what we think we're going to see. We think it's more likely that people with high levels of work-related stress, managerial roles have high levels of work-related stress than non-managerial roles. So we've got our random sample, 160 employed people. We start off by just describing, and because it was just between managerial and non-managerial, it's a slightly shorter sentence, but end of this first sentence here, we are making sure that we do a comparison. There's our keyword likely without quoting percentages. Then we quote the relevant percentages. This time it's the high stress for managerial, high stress for non-managerial. Again, keyword, we've got a higher in there, so we're actually doing a comparison. We're not just saying what the percentages are, we're saying what that, which one is bigger. Then we have our name of our test, so chi-square test, telling me about the relationship between work role and work-related stress. It was significant. We quote our test figures. And so, as expected, those managerial roles were much more likely to report high levels of work stress than those in non-managerial roles. So one thing you'll notice in this example, we were only quoting 2 percentages because we were comparing the high stress between the managerial and the non-managerial. So we didn't need to quote the other 4 percentages that were on that table. Okay, so that's it for this week. In fact, that's the end of new content. Do make sure you look at next week's material for some revision. Make sure you read Module 8. There's a SPSS video on how to do a chi-square test. And of course, this mirrors what's in Appendix A of the Francis and Gehring book. And make sure you complete topic test 9.
This has been a Swinburne production.